I'm going to show you how we can calculate a patient's heart rate looking at their electrocardiogram. To do that, it's helpful to mark on the ECG every P wave crest, the P wave's highest point. The next step is calculating the interval between two P wave crests. So we're going to start looking at this one, and we are going to figure out how long it takes until we get to the second heartbeat's P wave crest. I'm going to estimate that the crest of the first P wave is between small squares 2 and 4, but not quite on the line of the third small square, and instead in the middle. That means it will take me 2.5 small squares to get to the end of the large square. 2.5 small squares is the same as 2.5 times 40, which is representative of 100 milliseconds. The next step is pretty easy because I can just count large boxes as 200. So I have 1, 2, 3, 4, 5, 6 large boxes, and 6 times 200 is 1,200. I'm in luck because the crest of this next P wave looks to be right on the line. So I stop counting boxes and add up my total time. Once I do this, I have this distance calculated, and I have said, with my estimation, that it is 1,300 milliseconds. I'm going to do the same thing for the next P wave crest to P wave crest interval. And this time, I'm going to go to the right to my next P wave crest. P wave starting on the line, so I can start counting large boxes immediately. 1, 2, 3, 4, 5, 6. So if I have 6 large boxes, again, that's going to be 1,200 milliseconds. To reach my next P wave crest, I need to count a couple more small boxes. I count 1, 2, 3. 3 small boxes is 3 times 40, which is 120. I must now take the sum of these, and that gives me 1,320 milliseconds. This is a slightly different length from the first calculation that I did, but we really are talking about a very small difference of 20 milliseconds. However, if this patient was experiencing arrhythmias, these intervals could be quite different. I'm going to do the same process with my next P wave crest to P wave crest. So to calculate that distance, I'm going to start at the point that I ended and go all the way to my next P wave crest. To get to the end of the large square, I have to travel 2 small squares, which will give me 80 milliseconds. Next, I count the large squares and multiply that number by 200 because each large square is 200 milliseconds. So I have 1, 2, 3, 4, 5, 6 large squares. Again, 6 times 200 is 1,200. And then I have one more small square to go before I reach the crest of the next P wave. So I would need to add an additional 40 milliseconds. Doing that gives me a time of 1,320 milliseconds. Pretty much exactly the same as my previous heartbeat. Notice that I cannot do another round of this calculation because I have no more sequential P wave crests that I can see on the electrocardiogram. What that means is that I am ready to move to my next step. Now, I need to find the average distance between P wave crests. To do that, I'm going to add my first interval, my second interval, and my third interval. That gives me 3,940 milliseconds total. This is not the average. To find the average, I need to divide my total by the number of intervals that I measured, which in this case is 3. When I divide my total by 3, I get 1,313.3 milliseconds. 1,313 is not a heart rate. If it was, you'd be in a world of hurt. So this is not our final answer. So I have my average in milliseconds, but I want to convert that number into seconds. What I can do is multiply by 1 over 1,000, because 1 second equals 1,000 milliseconds. It's like I'm multiplying by 1. But this becomes especially helpful because it gets us closer to the units that we want. So we've calculated that each interval takes an average of 1.3133 seconds. When we measure heart rate, we are measuring it in beats per minute. And right now, our answer is in seconds. We know that it takes about 1.3 seconds for the heart to beat, and we also know that 1 minute is the same as 60 seconds. So in 1 minute, or 60 seconds, we need to figure out how many times this person's heart beats. So we take 60 and divide it by our average in seconds to make our units agree, and that will give us our average heart rate. I get a value of 45.6864. This answer makes more sense when rounded, so my final value for the average heart rate of this patient is 46 BPM. If we compare this heart rate to our normal range, we'll notice that the heart rate we've calculated is much less than 60 to 100 beats per minute. So this person's heart rate is in bradycardia. What that means is their heart rate is lower than normal.